So hello everyone, welcome to the lecture 4 of vector and kinematics series. So today we'll discuss about the few problems and examples that arises from the theory we have developed till now. So our first problem is the two vectors are given, and from that you need to determine the length of the vector AB. So and then the angle between the vector between the two vector and the area of the parallelogram that is formed by A and B. So so how do you obtain the length of AB? So this is the right-handed coordinate system. This is x-axis, this is y-axis, and this is z-axis. And let's say this O is the origin. So and here are the, let's say, 2 points A and B. Then and this is the position vector of A, and this is the position vector of B. And that is OA is the position vector of A, and that coordinate that vector we can in shorthand that OA is denoted by A, and in shorthand the OB that is the position vector of B is denoted by B. So now if you want to find that vector AB, that is this vector, that from the triangle AOB, if we apply that vector addition formula, then we get that OA plus AB is OB. Since OA and AB are in clockwise direction, and OA and AB is in clockwise direction, and OB is in anti-clockwise direction. So what is AB? AB is nothing but OB minus OA. Similarly, if you want to get that vector, let's say BA, then it acts to A from B, then you will get from the triangle AOB, OB plus BA is OA. Since OB and BA are is in anti-clockwise direction and OA is in clockwise direction. So what is BA now? BA is OA minus OB. So since BA is reversed of AB, so that's why these two subtraction that are reversed. So in shorthand, that AB is B minus A, and BA is A minus B. Right? So now what is AB? So AB is nothing but B minus A. So this is 3y minus 4z minus x plus 2y minus 2z. So this is nothing but x plus y minus 2z, right? So this is, so B minus A is nothing but x plus y minus 2z. So what is the length of AB? The length of AB is, this is just component, if you take the x component square, then if you have to take the y component square, and then you have to take the z component square, that is root 6 unit. Now the next question is the angle between the vector. So for getting the angle between the two vector, you need to first take the cross product of A and B. Why? Because that A and B, if you take the dot product, this is the dot product, if you take the dot product, that A B cos theta. Another way you can also determine the you can determine the angle between the vector, that is if you take the cross product A and B, and if you take the mod of that vector, since the cross product is a vector, you have to take the mod of that, and then this is nothing but mod of A mod of B sin theta, and that is sin theta is A cross B by mod A mod B. Similarly, from here cos theta equals to A dot B by mod A mod B, right? So you can determine the angle in two ways, that is from this dot product definition and also the from the cross product definition, but here you have to take the mod. So but you will see that this process is much more easier than this, because cross product dot product is easier to take rather than cross product, because the cross product, the determinant formalism will come. So we are using this process. So that is the cos theta is a dot p. So if you take the a dot p, then x plus 2y minus 2z dotted with 0x, since the x component is 0, plus 3y minus 4z. And what is the mod of a? Mod of a is nothing but minus 1 square plus 2 square plus minus 2 square, and then mod of b is 3 square plus minus 4 square. So that is the first x term is 0 plus 6 plus 8 by this is 3 and this is 5. So that is 14 by 15. So what is theta? Theta is nothing but cos inverse 14 by 15. And you can also obtain this in the that formalism, a cross b. So let us try this, and how and why it is difficult, and rather than this dot product formalism, let us watch that. If you take that now, a cross b is x y z minus 1 2 minus 2 0 3. So these are the components of a and these are the components of b. Now if you take the cross product and if you break the determinant, you will get this, that is minus 8 plus 6 minus y it is 4 and plus z minus 3, right? So it is minus 2x minus 4y minus 3z. So what is now mod of a cross b is nothing but root over minus 2 square plus minus 4 square plus minus 3 square. So this is root this is 25 29, right? So this is nothing but 29 and what is now sin theta? Sin theta is root over 29 by the mod of a is 3 and the mod of b is 5, root over 29 by 15. So how do we verify our formalism is correct? So if you take the sine square theta plus cos square theta, that is the sine square theta is 29 by 15 square, right? And what about the cos square theta? Cos square theta is that 14 by 15. So 14 by 15 square, you will get 14 square plus 29. If you calculate, you will get 15 square by 15 square, that is 1. So our answer is correct. So if you calculate the theta value in the calculator, then you will get this is nothing but root over 29 by 15. So this is just close to 21.03 degree, that angle, that theta. So in this way you can obtain the theta angle. So you just see that the second method is cumbersome rather than the first method, that is the cross product. If you want to evaluate the angle with the cross product, that is cumbersome. rather than the first method. So it's preferred to do with the dot product formalism, that is just A dot B. You need to calculate just A dot B. So the third thing is you need to calculate the area of the parallelogram formed by A and B. So the area is nothing but the area of the two vector A and B. So if you complete the parallelogram, that is A and that is B, the area vector, that is let's say S vector, that in this case it acts from the, if you take the product A cross B, the cross product actually acts the outside from the plane of the board, so that is S. So the area is defined by, the area vector S is defined by A cross B, that we have already seen. So actually in the previous part B you have computed the A cross B, and A cross B is minus 2x minus 4y minus 3z, that is minus 2x minus 4y minus 3z, right? So now if you calculate the area, that is mod of S, so the mod value also we have calculated, that is nothing but root over 29 here. So area is root over 29 unit square. So in this way you need to solve this kind of problem. In the second example, the sum of the two forces has been given, and it has been also given that the resultant vector is right angle to the smaller force, and the magnitude of the resultant vector is resultant force is 12 Newton. Then you need to determine the magnitude of the individual forces. So let us draw this diagram. That let's say you have a force, that is let's say P, and let's say you have another force Q. Here Q is at obtuse angle to P, since the resultant vector is at right angled to the smaller force, that is Q. So if the resultant is at right angle to Q, then the angle has to be obtuse, because it is greater than then the angle of P and Q definitely must be greater than 90 degree. So that's why this angle between P and Q must be obtuse. Now let us complete that parallelogram formed by P and Q. So this is the parallelogram. Now let's say this angle is theta, and it has been, and the resultant vector is R, and that is 90. So this is also theta, and this vector is Q and this vector is P. That's why this vector is also P, since these two sides are equal and they are parallel. So that's why this vector and these vectors are same. So now you know R is P plus Q, where the Q is the smaller force and P is the larger force. So now it has been also given that the sum of the two forces, that is mod of P plus mod of Q, that is let's say in shorthand P plus Q, that is 18, right? So and the resultant vector R, that is the mod of R, is of 12 Newton. Now what is in this triangle, what is, let's say if you take the sine theta is nothing but Q by P, that is Q equals to P sine theta. So that is one of our relation. Another relation is P plus Q is 18 and R is 12. So these things are known by us. Now what is, let's say that R vector. Now you need to determine the magnitude of the two forces, individual force, that is P and Q. Now you know that R is P plus Q. Now what is R square? R square is R dot R, that is P plus Q dotted with P plus Q. So the first term we will give you P square plus 2P dot Q, since Q dot P and P dot Q is same, since dot product commutes of two vector commutes. So the fourth term will give you Q square. So now what is P dot Q? So P dot Q is nothing but mod of P, mod of Q, and cos of angle between P and Q. That is, what is this angle? This angle is nothing but 90 plus theta, right? So that is cos of pi by 2 plus theta plus Q square. So that is P square, that's cos of pi by 2 plus theta is minus sin theta, right? So minus 2pq sin theta plus Q square. Now that is, let's separate that. Let's write 2pq sin theta as 2q times p sin theta plus Q square. And what is p sin theta? P sin theta is nothing but Q, that is p square minus 2q into Q plus Q square, that is p square minus Q square. That is, so ultimately we get p square minus Q square is R square, that is p plus Q and p minus Q is R square. And what is p plus Q is 18 and R is 12. What is R square? R square is nothing but 12 and 12 and p plus Q, that is 18. So that p minus Q, if you obtain this will be just 8. So you know p plus Q is 18 and p minus Q is 8. So now you have two equations, these two equations. So if you solve these two equations, you will get, if you add these two equations, you will get 2p is 26, that is p is 13. If you subtract this two equations, you will get 2q is 10, that is q is 5. So the larger force is of 13 Newton, the smaller force is of 5 Newton. So this is the. So in the third problem, the position vector of the vertices of the triangle unknown, and from that you need to determine whether the triangle is right angled, isosceles, or equilateral, or none of these. So let us proceed. So if you have a triangle like this, let's say the triangle, and this is A, B, and C. So let's say this is A, this is B, and this is C. So what is now, let's say you need to determine AB, BC, and CA. So what is AB? AB is nothing but P minus A, that is 4 minus, that is 2x plus y plus 2z, right? So what is now BC? BC is nothing but C minus B. So what is C minus B? C minus B is minus x plus y minus 4z. And what is CA? CA is nothing but A minus C, that is minus x minus 2y plus 2z, right? So now if you calculate the mod of AB, you will get 2 square plus 1 square plus 2 square, that is 3. So if you now calculate the mod of BC, that is minus 1 square plus 1 square plus minus 4 square, that is root over 18. Now if you calculate CA, then you will get this is nothing but 1 square plus minus 2 square plus 2 square, that is 3. So mod of AB is same as mod of CA. So from this you can determine that the triangle is absolutely isosceles. Sorry, it is isosceles. So now let us look whether it is right angled or not. So now let's calculate so how do you determine whether the triangle is right angle or not? You need to take the dot product between sides. So if you take the dot product, let's say, of AB and CA, you will get dot product of AB and CA. So this is nothing but 2x plus y plus 2z dot minus x minus 2y plus 2z, that is minus 2 plus 4, that is 0. So that is the AB is right angle to CA. So since the AB is right angle to CA, that's why there is this thing, that the ABC side, that is the angle ABC here, is 90 degree. So since the one angle is 90, so other angle will be of course of less than 90, other two angles. So if you take the dot product of other two, let's say ABCA, and let's say if you take the ABBC or BC dot CA, you will get non-zero value, of course, that you can verify too. So that's why, so you have the triangle like this. So this is A, B and C, and you know that the length of AB is same as length of AC, and AB and C are perpendicular, which is evident from this diagram. So the triangle is both isosceles and right angled. So these two options are correct. So now, and definitely these two sides are equal, and this is different from the other two, so that's why this is definitely not equilateral. So these two options are correct. So in the fourth problem, let's say in the fourth problem, let's say S is the midpoint of side QR of a triangle PQR. Then prove that PQ plus PR is nothing but 2PS. So this is the midpoint identity. This is known as the midpoint identity. So now the question is, how do you prove this? So let's take any triangle. Let's say that is PQR, and let's say S is the midpoint of QR. Then you need to prove that PQ and PR and it's nothing but that 2PS. This is the vector PS. So how do we proceed? So PS is the common side of the triangle PQS and PSR. So let us apply the triangular law in the individual triangle. That is, if you apply the triangular law in the angle in the triangle PQS, then what you will get? You will get that PQ, let's say, plus QS is PS. Since PQ and QS is in anti-clockwise direction and PS is in clockwise direction. Similarly, in triangle PSR, you have let's take the side to be in this direction, the RS. Then that PR plus RS is PS. So we are keeping PS in the right hand side. Since this, if you add these two equations, you will get 2 times PS. So that's why you are keeping PS in the right hand side. So how do you do that? So if you take the instead of RS, instead of SR, you need to take the vector along RS direction, and this is the only way to keep PS in right hand side. So if you add these two equations, equation 1 and equation 2, you will get PQ plus PR plus QS plus RS is 2PS. Now what is QS plus RS? So since S is the midpoint of QR, that's why the mod of QS is mod of RS. But the direction of QS is opposite to the direction of QR. Since QS acts from left to right and RS acts from right to left in the same line. So that's why the vector QS is opposite to the vector RS. Since the both have same magnitude but anti-parallel direction. So that's why the QS plus RS is 0. So this cancel out these two terms. So we are only left with that from this, that PQ plus PR is 2PS. So this is our midpoint identity. So this is what all I wanted to say now. So thank you. See you in the next lecture.